12y to the fourth power.
That's it. Very good. What about the next example? 12 over 6y to negative 4. How will I write this one? Anybody, please? How do I write this? Please, anybody?
12 in front, yeah. Is it a fraction?
It's the same procedure. There is nothing different.
Okay. Oh, 6y to the fourth power?
That's it. So then I have 12 times 6 to the fourth times y to the fourth. So I want to multiply here. Here's what I do. Go to the graphing calculator. Here it is. And clear. So I have 12 multiplied by 6 to the fourth power. And I get 15552. So 15552 y to the fourth power. Is this okay? Yes, no, maybe. Anybody, please.
Yeah, thank you.
Perfect. Let's practice 2m to the negative 7 power. Can anyone help?
1 over parentheses 2 n to the seventh power, negative seventh power, or
Okay.
seventh.
Yes, it was
Positive.
negative in the numerator. It's positive here. So I have 2 to the 7th times m to the 7th. And 2 to the 7th, I can tell you, is 128 m to the 7th. Let's take a moment and see if you have any questions. Any questions, please? Any questions?
Is that the final answer?
That is the final answer.
Okay, okay.
Yeah.
Okay, so my question is,
Yes.
so if it's 2 to the 7 and that's 128, so we just don't do anything to the m to the 7, or we just leave that completely alone?
But if you tell me what is m, then I will raise it to the 7th power. But if I don't know what m is, I can't. With the number, it was clear. I'm able of raising 2 to the 7th power. But I'm not able to raise m to the 7th power unless you tell me that m is 3, m is 5, m is negative 2, m is 100. But if you don't tell me, I won't be able to. Is this okay? Is this clear?
It's
Is it better?
better.
Good. Okay, moving on. Here's the next example. 2m to negative 7. Parentheses, no parentheses. So, what do you think?
Well, right off the bat, I think it's the next number.
You said it is what?
a mixed number?
It's
Two in the
it's,
front and 1 over.
yes. So
m to the
directly,
7th?
yes, yes, yes.
Oh,
We
it's 2 over. Okay. Okay.
But because 2 has power 1, I can't move 2 anywhere because it has power 1. If it had a negative, if it were in parentheses with m, yeah. But I can't. Is this okay? Do we understand the process here?
It
Yes.
just keeps getting harder and harder, but yeah, it's you are a great teacher.
Thank you. I can only hope that students can keep up because it's a lot. I'm trying to show you all types of problems so you have examples. Okay? Good. What about a -2m to -7? What do you think about this? Anybody?
Is it 1 over -2m?
Yes. -2m to which power?
To the 7.
Excellent. So now we have 3 factors. -1 to the 7th power, 2 to the 7th power, m to the 7th power. So -1 to the 7th power, what is that? -1 to the 7th power is a negative number raised to an odd power. What is the sign?
Negative.
Correct. 2 to the 7th is 2 to the 7th, m to the 7th. Well, we know that 2 to the 7th, you can calculate, we just had it a minute ago, is 128. Positive over negative has to be moved in front. The sign positive over negative has to be moved in front of the fraction line. So this is 128 m to the 7th. Okay, we reached the fractions now. So we have 3 over x squared raised to -2. We want to simplify this. 3 over x squared, everything raised to -2. What do I need to do now? We presented the rule a few minutes ago. Let's go back to the rule. If I have a over b to -3, I flip and I get b over a to the 3rd power. And of course, now I have b to the 3rd over a to the 3rd. I have to. So then, coming back to our example, what do we need to do next?
X squared over 3.
Everything to which power?
-2.
Careful. If I flip the fraction, the power can no longer be the same.
Right. 6.
Yes. And now I have to apply it as normally. X squared squared. I copy the base. What happens to the exponents?
Multiply.
Good. Divided by 3 squared, which is 9. Please do not. I know it's tempting to pick and choose, but we cannot do that. Everything has to be raised to the corresponding power. Got it? Let's look at another. See, you understand how important the discussions and interaction in class is. It's the only way to study these. No one was born knowing these things. No one. We all learn them. So you can too. Okay, so I have a fraction raised to -3. Don't even look at the fraction. What do I have to do first?
Flip it.
Yes. Yes. So I have -a³ over 3b. And now the power is
A +3.
exactly. Now from this point on, I know how to handle this. I have 1, 2, 3, 4 factors to raise to the 3rd power. Let's do it.
So negative
Yes,
a to the 9th,
yes.
and then
3 to the 3rd.
27.
Yes. B to the
3rd.
That's it. Done. Notice that I cannot continue. These do not have the same base. I cannot touch this. There's no exponential rule with different bases like this to simplify. Good. Next one. -13 m to the 5th n to the 8th over 5 m to -2 n raised to 0. We're asked to simplify this expression. One thing is for sure. When you look at this, you'll say, oh, okay, that is easy. What?
-8m to the 3rd.
No, I'm talking about this.
Oh. Hmm.
How much will this be?
1.
Exactly. Of course, the problem, if the problem doesn't say, we know that m and n cannot be 0 because they are in the denominator. So this is 1. So I don't even have to worry about it. It's done. Now I start with the numbers. -13 and 5, it has to stay. I cannot simplify them in any way, shape, or form. Now I'm looking at m and find the power. And n has to stay with power n with power 8 because there is nothing else. So 5 minus -2.
7.
7. And this is it. And this is final. Any questions? Any questions? Okay. -t to the 5th power, everything to -5. When you see a negative power, don't even look at what is inside. Not at the beginning. So, what do I get?
It's either flipped or a fraction.
So whatever it is, if it's a fraction, I'll flip the fraction. But if it's a quantity, all I have to do is write this. Good.
And then -t is flipped too.
No, I already flipped everything. A quantity to negative power is 1 over the quantity to positive power. This is done.
Even if the parentheses has a negative inside of it?
But now I will simplify. Now I have -1 raised to the 5th power and t to the 5th raised to the 5th power. I haven't finished. So first we have to raise -1 to the 5th power. What do we get?
Oh, -5?
No.
-1? -1?
Yes, -1. And then copy the base, and what happens to the exponents?
25?
That's
Multiply?
it. A positive over negative is negative. 1 over t to the 25th. Any questions on this? This is not a fraction. We have to use the other rule. So 3m to -4th power raised to the 2nd power. Now the power is positive. I cannot flip anything. I cannot move anything anywhere yet. So what do I get as a preliminary step or preliminary answer?
-9m -8?
Yes, 9m raised to -8th power. Good. What do I do now? Because we cannot leave negative exponents in the final answer.
1 over 9m.
Careful, I cannot move 9. 9 has a positive power. Nobody can touch it.
So 9 divided by 9 over m to the 8th power?
Yes, absolutely. I cannot move anything that has positive exponent anywhere. Good. 36. A to the 4th. B to -8. Everything divided by 9. A to -2. B to -6. Don't move terms or factors, I should say, anywhere. No, not yet. First, address the numbers. 36 over 9. How much is that?
4?
Perfect. Now we're looking at A. Copy the base, and the exponent is
2?
the exponent is 4 minus -2.
6?
Perfect. Now we copy the base, B.
-2?
Yes, B to -8 minus -6 is indeed -2. Final step, no negative exponents in the final answer.
No. 4 over a to the 6th power b to the 2nd?
I cannot touch a to the 6th. Nobody's allowed to touch a to the 6th.
But isn't that on the bottom?
Do you see it in the denominator?
Oh, okay.
What if I see a to the 6th in the denominator, then I see 4 in the denominator as well, right? There is no fraction line. So then 4 and a to the 6th must be left alone.
I have a question.
Yes.
Only negative exponents get moved to the bottom.
Yes, nobody can touch. We don't have any rule to move positive exponents anywhere. We only have a rule that allows us to move negative exponents somewhere, depending on where they are. But we have no jurisdiction over positive exponents. We can never touch those. We only have a rule on negative exponents. Positive exponents cannot be touched. They are carved in stone. Does that answer your question?
Yes. thank you.
Perfect. Perfect. Okay. Let's take a look and simplify 64 to the 3rd power over 4 to the 2nd power. There is a problem here. We have to be careful. One possibility is using the calculator. You cannot, they don't have the same base. You cannot copy something and subtract the exponents. That's not possible. One option would be 64 to the third is 64 times 64 squared. 2 plus 1 is 3. The denominator, I know that 4 squared is 16. I am allowed to simplify factors, and I'll simplify by 4. So now it's easier to calculate. I would put in the graphing calculator, and I'll calculate. You can calculate it from the beginning. So if I do calculate from the beginning, it's 64 raised to the third power, and divide by 4 to the second power. So from the beginning. But I made some simplifications, and should be fine. I simplified it to 4 times 64 squared. It has to be the same answer. If I don't get the same answer, I know I'll say, oops, and do it again. So this is 16,384. Good. Okay, 2 more before we look at 5.4, the other part. So let's say I have z raised to 6t minus 2 over z raised to t. This looks more difficult than it's not. Do I have the same base? I do. So I copy the base, z. Now what do I do with the exponents in this case?
Subtract?
Yes, from 6t minus 2, I subtract t. And I know how to combine like terms. So this is z raised to which power? 6t minus t is 6 apples minus 1 apple is
6.
5 apples minus 2. Is that okay? Is that okay, everybody?